Hello, I'm Brittany English, and today I'm going to be talking about object detection, specifically with rubber ducks, through the use of segmentation and multivariable considerations. Object detection can be used for a variety of applications, which include facial recognition, video surveillance. In this instance, the object detection would be to identify suspicious activity in a video. Item inventory. In this example, a factory could use object detection for inventorying their items, or damage prevention. For example, on new vehicles, image processing is used for object detection to identify vehicles that are too close to help prevent car accidents, or also to identify lanes so the driver will have a harder time drifting into a lane unintentionally. The problem scenario that we are dealing with is a toy factory wants to use object detection to conduct inventory of their collection of rubber ducks. So our goal is to find the rubber ducks. Current practices that are effective for object detection are segmentation, which involves either separating the image into parts or applying a pattern to the image. In this example, we have separated it into parts. So in the image we look for, of a rubber duck, we will look for beaks and eyes and bodies. So we've identified 3 parts of the duck, and we will search for those 3 parts independently and then combine them into a total object. So that is the type of segmentation that we will be using. But also, segmentation can be used in the form of a pattern. For example, a 4-square or a star pattern can be used, in which the sections that the segments that you identify are predetermined in the shape of this pattern, and you compare those sections of the potential object to a known object for a similar result. Also, multivariable helps to increase the accuracy of object detection. Obviously, the more variables you use, the greater chance you have of accurately detecting an object. These variables include size, shape, color, texture, location, etc. And some of these can actually be combined to add additional information. For example, location and size can be combined to see if there's a person in a image. If the person is close up to the image, they will be very large, and the base of them, their feet, will be lower in the image. But if the person is very far away, their feet will be higher in the image and they will be smaller. So the ratio between the location and the size could also tell us additional information. So sometimes these variables can be combined that way, but if not, they can be combined in a way that they don't play off of each other as they do with that ratio, but they still add additional information. For example, if you're looking for the sky in an image, you would know that the location is probably going to be at the top of the screen. You know you're looking for a shade of blue. You know that it's going to be very large, and you would know that it's going to be rectangular shaped as is the frame. Now, we have defined a rubber duck by the following aspects. The segments that it contains are a body, a beak, and 1 or 2 eyes. The color definitions are that the body will be yellow and the beak will be red or orange. These color definitions have been encoded into MATLAB using RGB scale, and the body shape is also considered for the duck. It is an oval shape. It is missing a section, so the curved back will kind of cut out a section of that oval, and it will contain a hole in it for the eye. And each of the segments, the size is considered. For this example, eyes are defined to be at least 20 pixels, beaks are defined to be at least 100, and bodies are defined to be at least 500. Now, for our algorithm, we take an image, and first we detect yellow blobs and red or orange blobs. After we have our blobs, we compare the size, shape, and color of these blobs to identify our segments of the duck. We look for bodies, beaks, and eyes. Once each blob has been identified as either a body, beak, or eye, or neither, and then thrown out, we iterate through all of the body blobs, and we ensure that an eye and a beak are associated with that body blob. And once we have met all of the requirements for what the blob is, and we've been able to associate all the segments into one unit, we combine the body, the beak, and the eye, and then we will classify that whole unit as a rubber duck. The algorithm will outline the duck in red. Now, here is an example of some fabric with rubber duck print on it, and there are 31 ducks that have an eye, a body, and a beak. There are some examples on the ends where there's no beak or no eye, and some examples down here. So this one's also missing a head. So these ones are correctly ignored because they do not contain all of the pieces to be defined as a rubber duck. However, all of these other rubber ducks, there are 31, and the algorithm is able to correctly identify all 31 of them. The algorithm is able to ignore the orientation of the duck, so we have them, you can see at all angles here, and regardless, the algorithm is able to correctly identify them. In this example, we have one rubber duck. It has some bubbles and foam on it, so there's a little bit of noise, but even though there's that noise, it is able to still identify our duck. It does not include a little section here for bubbles, but the outline is mostly correct. As I said before, the outline outlines the full duck, but it also outlines the beak. So we outline the body and we outline the beak. In this example, we have two rubber ducks, a big one and a little one, and both of them are correctly identified. This is kind of a top view, and even though we have a very small back curve because of our top view, we're still able to correctly identify both these ducks. This example, we see a side view of two ducks, once again a big one, a small one, and they're both correctly identified. And some yellow noise is seen in the faucet here, and that's, thrown out. So the algorithm was successful here. Here we have a rubber duck underwater. It does have a little bit of a reflection here that's correctly ruled out, but that duck is identified. Here we have that same rubber duck in the water. It's correctly identified. There was a little confusion in this one because the shadowing under the bottom side of the duck, a little bit of its bottom here is not included, and some of the shadowing in the back of the head has left out a section there. And a droplet on the beak has reflected a little bit of the orange, so that has been included. So the exact outline isn't 100% there, but we're still able to identify that that is in fact a rubber duck. This one, the duck is once again correctly identified, but as you can see, the shadowing here confuses it, and it actually, in this example, thinks that the beak is the section of the back of the head here instead of this front section here. It did see both those beaks, but it picked the larger one to be its beak incorrectly. But however, the duck as a whole is still identified. So there are some slight problems caused once again by